Oops. Keep. Your computer.
Good morning, everybody. Welcome to Australian Manufacturing Week 2022. It's great to see so many people out and about, having a look at what we have to offer. Here on the Omax Abrasive Force Jet stand, we're about to do a live link up to Seattle in the USA. We're going to have a chat to our good friends over there in the Omax Technology Center. They're going to take us through the latest and greatest in abrasive water jets, take us through how it works, and give us a quick demonstration. Okay. Okay, I'd like to introduce you to our team over in America, who very kindly agreed to stay up late for us. So in the center there in the blue shirt, we have Ivan. Give us a wave, Ivan.
Hey, everybody. How's it going?
Next to him, we have Kai. Say hi, Kai.
Hey, everybody.
Fantastic. Okay, so I'm going to hand over to you two because nobody's come to listen to me talk. Okay, off you go.
Matt, I'll listen to you talk anytime. Hi, everybody. How's it going? Welcome to our Advanced Technology Center here in Kent, Washington, right outside of Seattle, Washington, on the West Coast. This is where we build all of our Omax abrasive water jets. We occupy roughly around 23,000 square meter building here, and we are one of the few companies in abrasive water jet industry where we build all four major components here under the same roof. What are those components? Right behind me, our XYZ table, the high pressure pump, the control software, and the entire control system. And why is that important? Well, for once, everything is designed to work together. We're not buying software from one manufacturer, one company. We're not buying the table or the pump from somebody else and then trying to make it work together, right? This has been from day one designed to work together, and it has tons and tons of benefits there. And we've been doing this since 1993. We're knocking on 30 years doing this. Our founders were initially the inventors of the abrasive water jet cutting. So yeah, we are a employee-owned company, which is really good for obviously everybody here, as well as all of our customers. What does that mean to you as a current or potential future abrasive water jet customer? We're here to stay. We're all heavily invested into this, and that will benefit you in the long run. But that's enough about us. Kai, why don't you tell people about our equipment?
Sounds good. Thanks, Ivan. So to get started off, we are going to talk about our Maxium line. This is one of our most customizable tables. A couple features that we offer are the water level control right here. Allows you to raise the water up and down to cut underwater. And the benefits of that is that it will keep the noise down when the water jet is running, as well as keep the debris from garnet and water spraying and getting your shop all messy. As you can see, our white walls are still pretty white, thankfully, because of our water level controller. As you can see, this spinning head over here, this is also another feature that we have. It's our A-jet. And this allows you to cut bevels, weld preps, or anything that you can think of up to 60 degrees, this can tilt. And then you can also have different varieties of pumps. Right now we have a 50K or 3,400 bar pump on this big guy. And these are just some of the features that you can upgrade to. And I say that because if you just need a water jet to cut X, cut Y, a little bit of a motorized Z, you're good to go. We can set you up with that. And let's say down the road, you want to upgrade to the 5-axis cutting head. We can upgrade you then. If you don't want the water level, want a little bit more bed, that's fine. We can always upgrade you at a later time. And you might be asking how far later? Well, 5, 10 years, you are always guaranteed to be backward compatible with our equipment and our software. So now that's pretty much it for the Maxium line. I'm gonna go over here and talk about our Micromax line. Now this is the most accurate water jet on the market today. It has a cutting envelope a little less than 1 meter by 1 meter. And when you're trying to get precision, and by precision, I mean about 25 microns, if you can imagine that. We can achieve that by using this tilted jet head that we have on this machine. And now what that does is it takes the taper that is naturally created from the jet, taking away the metal or whatever material you might be cutting and tilting it into the scrap of the material, leaving your part with a perfect 90-degree angle. Another thing that we have on this is our 60K pump, and that will allow you to cut a little bit faster because this was initially compared to wire EDMs, but to cut at a much faster rate. So now let's go to our latest and greatest software. We have been working on this machine right here, the Optimax, for the last 4 to 5 years. This has been in development. This has all the bells and whistles you can think of. It has our water level control that I showed you earlier. It has our brand new upgraded VersaJet, which is our upgraded 5-axis cutting head. And it has a whole bunch of other features that we can go over in a little bit. But instead of me going over those features, why don't I just go ahead and cut a part for you, and I'll send it back over to Matt.
Thank you very much, Kai. Okay, so what
No
you're going to see
problem.
Kai do first of all, he's going to raise that water level up. And as he explained before, the reasons for bringing up that water level are twofold. First one is it reduces your noise levels right down. So you're going to go from being maybe 85 decibels, something like that when you're cutting in atmosphere. And with that level, you're going to need hearing protection. When you bring the water level up, takes it down to about 75 decibels. So that's then below the safe workshop levels for requiring hearing protection. The second reason is cleanliness. It keeps the splashing to a minimum, keeps most of it inside the tank, so you don't have any housekeeping or potential slippage issues. Okay, so he's now started the cut. So Kai, if you could just zoom out a little bit for us on the controller screen. So what you can see there is traditionally, when the machine's cutting, you see the part being cut in 2D. With the new Optimax, you can actually see the part being cut in real time in 3D. You can see the whole machine, you can see the part itself, you can see the head tilting over there. So with the VersaJet, we can go up to 60 degrees in tilt and continuous rotation. So the system never has to stop and unwind itself. It can just sort itself all out with the programming. The Optimax is Industry 4.0 ready. All the sensors feed back to the controller, and they can give the operator maintenance planning information, so you can make sure you minimize your downtime, maximize your production, and keep running. So in terms of the range of machines that Omax do, it starts at the Proto-Max. The Proto-Max is a 300 mil square abrasive water jet. Great for prototyping, does up to 25 mil thick materials. All of our water jets will cut the same materials as each other, purely because this is a high-speed erosion process, cold cutting. And what the cold cutting actually means is that you don't put any heat into the material whatsoever. Other methods like plasma, laser, they're all using heat and light energy to melt the material, which means it changes the mechanical properties of the material at the cut face. Water jet cutting doesn't do that. It just erodes the material away very, very quickly, leaving you a really nice sandblasted finish. So after the Proto-Max, we go up to the Global Max. The Global Max is our entry-level system. Comes in system sizes from 1.5 meters by 800 meters up to 2 by 4. It's a great system if you just want to cut flat, two-dimensional parts all day, every day. It comes with a Maxium style direct drive pump, 500-hour maintenance cycles, 45,000 PSI cutting. From there, we go into the Omax range. Now, the Omax range is the mainstay of the Omax line of systems. Again, ranging from sizes 660 millimeters square. If you really want to, you can go all the way up to 4 meters by 20 meters. And from there, we go to the Maxium. The Maxium is the workhorse range of the Omax systems. It has the Intellitrax Drive. Let's talk about that for a second. So the Intellitrax Drive is the only drive system that's been invented solely for abrasive water jet cutting. There's no other drive system in the world that has been specifically designed to run on an abrasive water jet, other than the Intellitrax. It uses traction drive, so there's no mechanical interface. And the fact that we have no mechanical interface means there's no lubrication required. So there's no lubrication required. The maintenance is exceptionally simple. It has a 1 micron closed loop feedback system. So it means that the machine knows where it is at any stage. So if you if the machine loses where it is, or you lose power and you have to break away from the part and come back, the machine knows where it was and it can just continue from where you left off. So from the Maxium, we go up to the Optimax. And as we've already said, this is the latest and greatest in abrasive water jet technology. You can see the head tilting over there. Coming up to the last part of the part. How long have we got to go, guys?
We got about 30 seconds over here, Matt.
All right, only 30 seconds more of padding, we'll be fine. So the nozzle they're using on that one today is the MaxJet 5i diamond integrated nozzle. That is prorated up to 500 hours, but we regularly get reports back from our customers of them lasting long over 1,000 hours. So I'll let you do the maths on that one. So it's just coming up to the last part of the cut now. It's traversing out. So I'll hand you back over to Kai, who's going to fish that part out and talk you through it.
All right, Ivan's gonna assist me in getting this part out of the material. I'm just gonna move the machine out of the way as I lower the water. And here we are with our finished part. So now, some cool things to note is that sometimes your scrap is almost just as cool as the part you're cutting. You can see here with these angles, it kind of looks like a little orb right here. Pretty cool. But the parts that I really want to show you are these parts right here, which are actually just scrap, but they are thin angled aluminum. As you can see, there is no heat damage or heat treated zones or anything like that. I'm clearly handling the part as it just came straight off the table. It's cool to the touch. And this part right here could be programmed if you wanted to cut these parts over and over and over again, because our machine is that accurate and that spot on.
So that part there, that could be your finished part. All right. In this instance, as Kai says, that's the scrap. But you can program your machine to produce those parts repeatedly, again and again. Carry on, Kai.
Yep. And so we got another one of those guys right here. Now, as you can see with our part, we did a 45-degree countersink right here in the middle. And this could be used for many uses in construction or various needs where you might need a bolt through hole or something like that. And then we have these two kidney-shaped slots right here, and those are cut at 30 degrees. Once again, this cutting head can go anywhere from a straight up 90 all the way to 60 degrees. And then you can see that there is a 45-degree bevel around the entire part. And then it came up right here, gave it another quick 45. And then there you go with your finished part. There's maybe a slight little burr on the back, but nothing that I could just get off with its own material. Just a little sandpaper right there, and it's good to go. And what I want you to note is actually this finish right here. As Matt said before, it's kind of a sandblasted finish. And if this needed to go to secondary machining, it is ready to go. If you need to go to powder coat, off it goes, ready to go. And there is, once again, no heat affected zones at all. And so if this needed to go to a mill or something like that, where it needed secondary tooling, those tools would not be at risk of damage because there's no hardening done to this material. And I'm going to send it right back over to you, Matt.
Thank you very much. Okay, so that gives you an idea, guys, of the kind of thing you can achieve with an Omax abrasive water jet, especially with the addition of the 5-axis head. Okay, so we're going to look to take some questions. Anybody got any questions? I promise they don't bite. Yeah, we've got a question straight off the bat today, Ivan. Here we go. Oh, go. It's all right. He's a bit mic shy. I'll ask the question for him. Yeah. Yep, okay. So the question is, step files. How do we load up step files and use those to program the water jet?
For sure, for sure. Actually, very easy. Omax machine will come with one of our suites of software that we call Intellicam. And Intellicam, it will accept a step file. You simply upload your step file into Intellicam, and it actually gives you a few choices. You can send it straight to the machine, where Intellicam will do all of the pathing for you, and it will just spit the file ready to go. It will pick up the thickness. All you got to tell it is what kind of material you're cutting, right? Say aluminum, stainless, stone, whatever that material might be. Another option is you can send it to Layout, which is our CAD side software, and there you can actually modify it. You know, maybe you want to add additional holes, maybe you want to take out some features. And from there, once again, you will send it back to Make, which is our CAM site. So yeah, so it's extremely easy to handle step files.
Okay, fantastic. Thank you very much. Any other questions? Yep, we've got another one. Just give me a second. I'll just walk over the other side. Oh, two-part question. Okay, we'll answer that one first. Okay, so the question was, if we had a number of step files, could we process all of the step files and the system nest them into a cut?
Yes. So you will bring in those files into Intellicam. So Intellicam will only handle one step file at a time, but from there you will simply continue sending it from Intellicam into layout, where it will park them essentially next to each other. And from there, obviously you will open Omax Make, which is the cam side, and you will be able to start machining. That's one way of doing it. Another way of doing it is using ProNest. ProNest is our advanced nesting software. There you can actually bring all of the step files, dump them all in there, and then send them to machine from there.
Okay, part two. Yeah. So I'll take this one, Ivan, actually. So he's
Go for
asked if we want to do 10 of the same part, do you do one that multiplies? So you have a couple of ways you can do that. So you have the Pro Nest, which Ivan was just talking about there, where you can actually have 10. You can nest 10 into the sheet size. You can nest 10 into however you want. If you want to just program that one part, we also have what I like to call a step and repeat function. Okay? So when you do your auto pathing, it will automatically work out where to make the part stop or where to finish that cut path for the next one to start next to it and be perfectly nested together. And it does that as standard. Okay, so when you'll go into the Make software, there's a little box where you put in how many do you want to cut, like say 5, and it will step and repeat 5 times until it's complete. Okay? Fantastic. Any other questions? Yep, another one.
Just after machining for this, if it's in stainless, does it need passivation afterwards, or is it because it's not needed?
Sorry, a bit of clarity. Passivation? Needs to be cleaned. Okay, so the question is, straight after cutting, do we need to clean or tidy the part at all? Is that correct? Passivation for stainless steel. Ivan?
I think what's being referred to is if it's like, you know, I might be wrong, but it's like going into food grade kind of stainless. Is that what you're referring to as passivation?
Oh, sorry, acid pickling. Right, okay. Now I understand. So have you heard of acid pickling? So it gets rid of any staining. So when you cut stainless steel on a laser, you'll get a burnt edge. And you do an acid pickling process to get rid of the discoloration and bring it back to the metal. So the question is, and I could probably grab him apart to show him, the question is, do we need to do any work
Big gear.
to bring the cut edge back to metal?
For sure. The simple answer to that is no, you don't need to do anything. It's simply water. You pull it out of the table, a little bit of shop air, right? We blow it off and the part is ready to go. This is a good example right here. This is 25 millimeter gear that was cut on the machine and there was nothing done to it. This is the finish. It's just raw stainless. There was no heat, therefore no need to, there's no discoloration of any sort, so nothing needs to be done to it.
Fantastic, thank you. So while you've got that gear part, is that the one from the display stand that I saw behind you earlier? Can you explain the purpose of that display stand for us?
Oh, sure.
The 3 gears on it.
Yeah, hang on, let me, I'll just move over there. This is the lightest sample I have. All right, so Kai, if you want to zoom in on this. So this is just a little display we put together a while back to show progression of our software. One of the things you have to realize with any machine tool out there, software is huge, whether it's a laser, whether it's a plasma, water jet, mill. However, with the water jet, it's a little more involved than that because you're essentially machining parts with a liquid tool, a wet rope, as somebody once said. And you need a lot more control over what you're doing with that liquid tool. And that's where back in 1993, we realized that G-code simply not going to cut it. The simple, A to B type command will not do the job. So what we've done, we've started developing our own software. And this shows the last 4 or the last 3 generations, I should say, out of 4 total. So there was somewhere over here, generation 1, and then this was generation 2. So in generation 2, this part right here, the smallest gear, took 30 minutes to cut on a 50 horsepower pump. And then fast forward a few years later, we released generation 3, where we learned few things and improved few things, of course. And as you can see, it's a slightly bigger gear. It has a couple more teeth, yet it still took 30 minutes to cut on the same exact pump, same exact machine. The only difference here was switching the generations of the software. And then fast forward to 2008, 2009, when we rolled out Gen 4. Now, once again, 30 minutes, 50 horsepower pump, same machine, same nozzle, same everything. The only thing changed was what generation software we used. And this is huge because one of the things Omax offers is a lifetime software upgrade. So you as a customer, doesn't matter if you bought the machine back in the mid-90s or you bought the machine now, you will get upgrades of the software at no cost. So for example, you buy a machine today, tomorrow we come out with cutting generation 5. You will get that cutting generation software and you will be able to cut faster. Matt?
Okay, so let me just re-emphasize that point. On those gears there, so if you bought a machine 20 years ago, you could cut that small gear, G2. Now, for no extra cost on exactly the same machine, you can now cut that G4 gear in exactly the same amount of time. So those increases in performance were done purely by understanding the behavior of an abrasive water jet, how it behaves in certain materials, how it behaves in certain geometries. And that is given to our customers completely free of charge. All you need to do is go on, download the latest software, install it on your system, and it's yours. Okay, any more questions? Yep, we've got another one. Yes, you're correct. So with the Intellicam software, you bring in your solid model, and the Intellicam software literally takes care of everything for you. So what I'll do is, once we've finished here with Ivan today, I'll take you over there and I'll take you through it. I'll bring a model in and I'll show you exactly how it works. All right. What type of solid model package do you use? Inventor. Okay. Ivan, Inventor, do we have a plugin?
That is a great question. I do not know the answer.
Okay. I'll find out. Then.
Sorry.
I'll let you know.
Sorry.
So just so you know what the plugins are, is within your software, if we do have a plugin, I'm sure if we don't, we'll probably come up with one soon, is that an Omax button magically appears within your Inventor software. So all you need to do then is you don't even need to use the Intellicam. You just press that button within Inventor, and it will give you the OMX file that we use, which is a 3D pathing file for the system to read and run. So it goes direct from Inventor to make. Yeah. Okay, any other questions?
So to jump back to the Inventor, I hit the easy button of F1 help, and I typed in Inventor. Inventor is Autodesk software, and we do work with all Autodesk software. So yes, there will be a plugin for the Inventor.
Fantastic, thank you, Ivan. Okay, so in terms of other ways of bringing in files, what else can we do?
There are literally tons of ways. We accept over 60 file formats where you can just simply click import from CAD and bring one of those 60 file formats and counting. We pretty much go after whatever the popular file formats out there. We make sure you can use those file formats to bring them into Omax layout or make. And then, as new file types are being created and once they gain popularity, we also make sure those get added. Additionally, just like we looked at Inventor, Fusion 360, SolidWorks, Rhinoceros, you name it, all of your biggest suites of software, Matt, you mentioned it earlier, you can install the plugin for our software and you just get the magic button somewhere up on top of your screen in your design software. And from there, once your part is designed, you hit that button and it creates the file that's ready to go on our machine.
Fantastic. Now, one other thing I wanted to just talk to you about before we go is one of the biggest questions we get asked, and we've certainly been asked it a lot this week, is how thick can you cut? How thin can you cut? How big? How small? All those kind of things. Have you got something
Sure.
you've got there that you can show us or demonstrate?
Yeah,
this?
let me just grab it really quick. So you guys earlier saw me handling this stainless gear, right? And I'll get Kai to help me with the camera here. So this is gear, as you can see, it fits in my palm, and it's about 25 millimeters thick. Okay, so no problem, we can do that. But what I want to show you is this little guy right here. So this is about 0.5 millimeter thick stainless piece with few holes on it. I'll just rotate it so you can see the tiny little holes. Okay, but we can go even smaller from there. There's another tiny little gear, and I'm afraid to cover it with my finger because it will just disappear. The beauty here is it's all stainless. It's all done on the same machine. You don't need any kind of special tooling. You don't need any kind of special clamping, none of that. Just change the material on the table, tell the software, hey, you're no longer cutting 25 millimeters thick. You're going to be cutting 0.5 millimeter thick. And the software will do all the adjustments for you and you will be ready to cut that part, okay? And from there, just since we're here and since we're showing off, this right here is 275 millimeters thick. This was cut from top down, okay? I don't know how well you guys can see. Sandblast finish, fairly smooth, no burr on the bottom, okay? There is a little bit of run out from top to bottom, but nothing too crazy. It's really, really low tolerance run out. And once again, going back to what we've been talking about, this is a cold erosion process, right? So our part was never warping, it was never heating up, and never changing its structure, okay? And it is a kind of a cool part too, because we also have some etching on it. Up on top, we have single line etching, okay? And this is just how you see it. It was drawn in single line. We come in and we etch this out. The one below is what we call Intelli Edge. It's another little software that's within our software. It comes standard with the Omax machines. And what it does, it basically takes a black and white image or clear contrast image, and it converts it into this bitstream type file, and it allows you to do this type etching. And this is done kind of like an old school printer, if you will. It just starts one line at a time, and it just goes back and forth, back and forth, back and forth. It takes a little bit of time, but you get a really, really neat result out of it.
Fantastic. Thank you very much. And I think that well and truly answers that question. Okay. Any more questions to come from anybody watching? We've got quite a crowd here today, which is good. I'm spinning around, but no. Okay. I think that'll probably conclude our proceedings for this morning. Thank you very much for staying up, guys. Really appreciate your time.
No problem. Happy to do it. Thank you, everybody.
All right, fantastic. So for everybody, there is another one at 2 o'clock this afternoon, which is going to be our last one for the show. I promise I'm not going to sing or anything, so we'll be okay. All right, so